So earlier in the section, we found the graph of f of x equals e to the x, and it looked like this. We got that from reflecting the graph of the natural logarithm. I want to look at some properties of that graph. First of all, it's increasing. It goes up from left to right. If you put in a bigger x value, you get a bigger f of x value. Secondly, it is continuous. It's all one connected piece. So there are no breaks in this graph. The domain of e to the x, the values of x that you can plug in there, you can plug in positive, negative, 0, anything there. So our domain is negative infinity to infinity. And then the range of e to the x, this is a positive base. It doesn't matter what power you take it to, it's always going to be greater than 0. And you can see that this graph is all above the x-axis here. So your range is just going to be from 0 to infinity. So positive y values for our range. As x goes to infinity here, e to the x also goes to infinity. So e to a big positive power gets bigger and bigger. Limit as x goes to negative infinity of e to the x is 0. So as x goes to infinity, you're going this direction. You can see our function values go up. As x goes to minus infinity, that's this direction. You can see that our function values taper off to level 0, which is that 0 right there. So we can use some of these properties to actually find limits that involve exponentials. So here we want to find the limit as x approaches negative infinity, 2 plus e to the negative 2x over e to the negative 2x plus e to the 2x. So we've got e to the x here, e to the 2x right there, that will behave similar to e to the x. So as x goes to negative infinity, this is going to approach 0. And then e to the negative 2x, well, e to the negative 2x goes down from left to right like this. So that's y equals e to the negative 2x. So it's almost a mirror reflection. It goes down a little bit steeper than this one does. But notice here as you go out to negative infinity with e to the negative x, it goes up to infinity. And that's because if you plug a big negative number in here times negative 2 makes a big positive. E to a big positive power, that's going to go off to infinity. And then the same thing down here. This is going to approach infinity. So we've got in 2 plus infinity over infinity plus 0. That's infinity over infinity. We do not know what's going on there. That's an indeterminate form, infinity over infinity. So what is that limit? Well, we can't tell the way that it is, but notice here in this problem, e to the 2x goes to 0. Okay, we'd like all our values of exponentials to approach an actual number here, not infinity, because we get this indeterminate form where we can't tell what's happening. So I'd like to change these all to positive powers in the exponential, and I can do that with a little bit of algebra. So I'm going to look at limit as x approaches negative infinity, and we've got 2 plus e to the negative 2x, and then over e to the negative 2x times e to the 2x. And then I'm going to take and I'm going to multiply top and bottom of that fraction by e to the 2x. So e to the 2x over e to the 2x, which is just multiplication by 1, right? And the reason I did that is because when you multiply this in here, first you've got, so this will be limit x goes to negative infinity, and then e to the 2x times 2 will be 2e to the 2x. And then e to the 2x times e to the negative 2x, those are both base e. When you multiply exponentials with the same base, you add those exponents. Well, negative 2x plus 2x is 0, so that's just plus e to the 0, but anything to the 0 power is 1. So that's actually plus 1. So now we've got a number there instead of e to a negative power. Same thing on the bottom. E to the 2x comes in times each of these guys. So e to the 2x times e to the negative 2x is e to the 0, which is 1. E to the 2x times e to the 2x, you're going to add those exponents when you multiply. So e to the 4x. And now we can actually tell what's going on. X go to a big negative power with e to the 2x, that's going to approach 0. And then in the denominator, we've got that 1, and then e to the 4x is also going to approach 0. So now we've got all numbers, no infinities left, and that limit is 1. So now if we were looking at the limit as x approaches positive infinity, and we're looking at this graph, then we would want negative powers instead of positive powers. So you just want your exponentials to approach numbers instead of infinity or negative infinity.